these are the notes for lesson 5.1, part 2, graphing quadratic functions in vertex and intercept form. So in part 1 of 5.1 we looked at graphing in standard form, and in this part we are going to look at graphing using vertex and intercept form, which are the other two forms that you will find your quadratic functions in. So we're going to start off with the vertex form, and that is y equals a times x minus h squared plus k, and that's where the vertex is hk, the axis of symmetry is x equals h, and a represents the vertical stretch of the graph. Now this may look familiar to you. If you remember when we looked at functions after chapter 1, we looked at the absolute value function. So if you remember, the function looks like this. We talked about how h and k make up the vertex, and then a is your vertical stretch or shrink. So the same thing is true with the quadratic function. So we have an a, and again that tells us our vertical stretch or shrink, and our h and our k make up our vertex. So from standard form to get to vertex form, we have to complete the square, and we're going to talk about what that looks like in the next section. So if our function is in vertex form, the first thing we need to do is determine the vertex, and we can see that right in the equation. So our equation comes from our h and our k. So in this case it is 1, 2. So on our graph we can plot 1, 2. Now the same is true with vertex form as standard form. Actually, our a value determines whether our parabola will open up or down. If it's positive, then it's going to open up. So notice there's no number in front, it's just a positive 1. So this parabola is going to open up. Now for part 2, we need to choose an x coordinate. Again, it does not matter which x coordinate you choose. The easiest one that you're going to find is the y-intercept, so an x coordinate of 0. Again, you don't have to use the y-intercept, you can use any other point on the graph, but x equals 0 or the y-intercept is just the easiest to plug into your function. So if we plug this in, we get y equals 0 minus 1 quantity squared plus 2. So y equals negative 1 squared plus 2. So y equals 3. So we now have the point 0, 3 on our graph. Then from here, just like in the previous section, we're going to find the axis of symmetry. Same as before, the axis of symmetry is your x coordinate in your vertex, so x equals 1. Once we find our axis of symmetry, we're going to use that to find our other point. So notice the y-intercept and our axis of symmetry are 1 unit apart on the left-hand side. So on the right-hand side, they're going to be 1 unit apart as well. So that is the graph of my parabola. So you may notice that the steps for graphing in vertex form are very similar to those in standard form. The difference with vertex form is that your vertex is a lot easier to see in your equation than it is in standard form. In standard form you actually have to solve for your vertex. In vertex form you can just pick it out of the equation. So example 1, we're graphing from vertex form. So our function is y equals negative x minus 2 quantity squared minus 2. Notice our a value is negative, so this parabola is going to be opening down. First thing we need to do is find our vertex, and again that comes from our h and k values. So our vertex is 2, negative 2. So if I plot that on the graph, the next thing we need is that second point. Again, it does not matter what point you use. I'm going to use x equals 0 just because I feel like it's the easiest one to find. So we're going to plug that into our equation. So I have a negative 0 minus 2 squared minus 2. So y equals a negative 4 minus 2, which is negative 6. So my second point is 0, negative 6. And again, that's the y-intercept. So then from here we need the axis of symmetry. Again, it's just the x value of our vertex. So x equals 2. So we're going to draw that vertical line through our vertex and label it. And then with that we can find our third point. So notice the y-intercept and the vertex are 2 units away. on the left side, so we're going to do the same on the right side. Connect your dots, and that is our parabola. The next form for a quadratic function is intercept or root form, and that's y equals a times the quantity x minus p times the quantity x minus q, where the x-intercepts are p and q, and the axis of symmetry is halfway between p0 and q0. So to get from standard form to intercept form, we have to factor. So to graph from intercept form, we first need to identify the x-intercepts or the roots. Again, these are the solutions that we found in the first part of chapter 5. So if we set each of these parts equal to 0, that will give us our roots or our x-intercepts. So x minus 1 equals 0, and x minus 6 equals 0. So x is positive 1, and x is positive 6. So our roots are 1, 0, and 6, 0. So we can find those on our graph. So we can go over 1 and over 6. The next thing we need to find is our axis of symmetry. Now, if we look at our graph, we're looking at the distance between these 2 points, and we're going halfway between. So if we count the units between these 2 points, that would be 5. So halfway between that would be 2.5. So I'm going to count over 2.5 both directions, and that will give me my axis of symmetry halfway between those points. So this is going to be the point x equals 3.5 or 3.5. And the last step we need to find is our vertex. So we're going to use the axis of symmetry to find the vertex. Now in order to do that, remember our x coordinate is also the axis of symmetry. So we know that our x coordinate for our vertex is 3.5. Just like we did in the previous forms, we can plug that into our equation to get our y coordinate. So we just plug in 3.5 wherever we see an x in our equation. So if we simplify this, we get y equals 2 times 2.5 times negative 2.5. And again, if we just plug that in our calculator, we get y equals negative 12.5. So our vertex is 3.5, negative 12.5. I'm going to go down by 2's so I can fit it on the graph. So I'm going to go down negative 12.5. So my vertex is down here. So 3.5, negative 12.5. And that is my graph. And again, in intercept or vertex form, your a value, if it's positive, it's going to be opening up. If it's negative, it's going to be opening down. So it's a good way to check your work to make sure that your function is opening the way it's supposed to. Example 2, again, we're graphing from intercept or root form. So we first need to find our intercepts or roots. So again, we're setting each part equal to 0. So x minus 1 equals 0, and x plus 1 equals 0. So our roots are 1, 0, and negative 1, 0. Because x equals 1 and x equals negative 1. So we can graph those on our graph. So at negative 1 and 1. And then we're going to find the axis of symmetry. Again, it's halfway between these 2 points. So it's actually going to be on the x-axis this time. So x equals 0. From there, we need to find our vertex. So again, we're going to plug in that x value to get our y. So y equals 4 times 0 minus 1 times 0 plus 1. So y equals 4 times negative 1 times positive 1. So y is negative 4. So our vertex is 0, negative 4. So if we go to our graph, go down 4, and connect our points, that is the graph of our function. Again, our a value, our 4 is positive, so our function is opening up. So again, there are 3 different forms that we can use to graph quadratic functions. Again, you always need 3 points in order to graph a function. So once you find the vertex, you have to find those other 2 points. Or once you have the roots, you have to find the vertex in order to get those 3 points to graph.